Good morning. As with anything technical, I'm IBM, and nothing can go wrong with the problems. Let me introduce myself. My name is Mark Ploszay. I'm the IBM Global Defense, National Security, and Law Enforcement Specialist. My background is I did basically about 22 years in the military as a military intelligence analyst. I also worked for a national security level agency for a number of years. And then I did 6 years in the UK as a law enforcement civil intelligence analyst, working primarily homicides, counterterrorism, and serious crime. Now, what we're going to look at today in a very, very short time is what's visual analysis. Okay. Visual analysis is taking vast quantities of information and moving it down to something that we can actually work with. The human brain has limitations on how much data you can use. You can think of it as a card file. If you're working with a card file of, well, let's say 100 cards, no problem at all. What happens when you get up to 1,000 cards? Well, some of our projects are now working the equivalent of 1 trillion records. Try to think of what you would do with 1 trillion records. And now, we'll see if it'll work for me.
Technology enables untold opportunities for consumers, for organizations, and for criminal exploitation. Because with technology comes a massive amount of disparate data. Data that criminals and perpetrators use to mask their identities and activities. How can organizations and agencies simplify trillions of disparate data points fast enough to identify actionable insights and act before perpetrators do? IBM helps you unleash the wealth hidden in big data by automatically resolving seemingly unrelated entities 24/7, so you can run complex queries across hundreds of terabytes of data and apply three-dimensional advanced analytics all at the same time. An integrated system of insight that transforms data complexity into actionable intelligence within seconds. That's the power of Big Blue innovation. That's the power of IBM i2.
Well, that's my commercial, and that's also my world. We've got roughly 19 minutes now to cover something that I would normally do in a week to 2 weeks of training course. So we're going to look at some quick things. We're going to look at how we're using visual analysis in law enforcement. As you're seeing there on the list, we cover things like telecommunications. We use association. We look at geographic intelligence. And what I'll do is, after I go through this, I'll show you examples of how we're actually using all this material. But it's not only law enforcement. We're also using it in defense operations. For all of you people who've ever worked within the defense and national security environment, these are the INTs. SIGINT, ELINT, HUMINT, OSINT. The thing to keep in mind is these are not potential uses. These are things that have been used for the last 20 years that we've been developing these ones. Some of the actual missions that we're involved in are things like COIN, counterinsurgency operations, cyber warfare. Cyber is developed into an entirely new development within the security and warfare section. The problem we have now is data, and we'll cover that. We're no longer restricted on data. We no longer have a shortage. As a matter of fact, we're drowning in data nowadays. We've been doing things like counter-piracy. I've worked on Task Force 125, working in Somalia. So all of our material is used within that area as well. Border security, force protection, and something called human terrain mapping. This is a different approach. It's also known as human terrain or human geography. And what we're looking at now is something other than traditional defense approach. We're looking at things like demographics, ages, ethnicity, basically all of the things, religion. We're looking at things like the upkeep of areas, infrastructures. How do they affect our operations nowadays? Okay, what we were saying is, what do we need a visual analysis for? Well, we're going to take 1 million records, and I'm going to take it, I'm going to correlate it together, I'm going to simplify it, so where I can now look at a representation and make an informed decision. So I can extract information and then prove it on so you can actually make intelligence operation out of it. One of the things that we came up with is alerting. We're finding now that analysts who are working with megabytes, petabytes of data, they'll ask a query on Monday. Have we seen anything on this person? Have we seen anything on this location? In my 2 petabytes data, I have nothing. But I have 1 billion records a day coming in. Now, do I every day want to sit there and write those same queries again? Hundreds of queries over and over again. No, we don't. So what we have built in is an alerting system now. Basically, what it'll do is it runs the queries for you. If it finds something, it pops it up and says, look, this report came in this day, you may want to take a look at it. The other thing we use is for blue-on-blue operations. If you're running an operation that you have a person of interest, a place of interest, and someone else starts asking questions about it, you want to be able to cooperate and coordinate beforehand. Okay, here's some of the things that we're looking at. We designed this system basically for the common man, the analyst. Excellent. So what we did is we made it as simple as possible. We built it so you can build a query using pictures. Find me a crime. All right, for this crime, I want to know everyone who's associated with it. I also want to know all their vehicles for anyone associated with that particular criteria. The system goes in, automatically finds it, and comes back with your records right there. Who it is, what were they associated with? Was I looking with drug dealing? Was I looking for murder? What was I looking for? Who was involved? And I instantly bring that back. And now I have the ability to expand on it, dipping in and out of our databases constantly to try to see, am I interested in this person? No, I'm interested in this one. Anyone who's ever been a intelligence analyst or an operator realizes for every question you ask, a good analyst will generate 3 to 5 more questions for every answer he receives. Geographics. Traditionally, there have been 2 kinds of analysts. You've had your traditional intelligence analyst on that side. You've had your geospatial analyst on the other side. Well, what we found now is it's easier, it's faster, and it's more effective if we allow people to do both. So when they build their chart on the right-hand side there, they can now instantly transfer it over onto a map. But it's an interactive map. It means now I can query the map and say, well, I'm interested in this particular organization. I'll click on it on the map there. It'll flip up over here, and then I now have the option of expanding and going further and further into it, visualizing it as it comes along. We looked at things like social organizations. In a vast group, it's difficult to tell what are the organizations, who's who, who's in touch with each other, what can we do? Within our tools over here, we've designed it so we can bring in things like photographs. We can bring in satellite imagery. We can bring in links directly back to a document so that the analyst has a complete wealth of information right at their hand. And that's when we developed a new, well, it's not a tool. It's been around for a while, but the power is immense. It's called social networking analysis. And it has absolutely nothing to do with Facebook or Twitter. Nothing. It looks at group dynamics. And within that, using algorithms and basic rule theories, we can now go in and say, who is the key person within a group? Or better yet, who are the watchkeepers? These are the people who control critical lines of communication. Now, you're saying you're looking at a chart like that, no problem. I can see instantly who the critical people are within the groups. But what happens if you're looking at 500 people or 5,000 people? The charts get absolutely enormous. Well, using this tool now, we basically have the ability to go in and identify these critical people. We use things called nearness, betweenness, to identify the critical person on that within. We can identify the top 5 immediately. And you'll see in a moment why this is of interest to us over there. Immensely powerful tool. Basically what we did is we had it compared, we ran a comparison through what would normally take an analyst 3 days using pen, paper, and hand drawing. They were now doing in less than 30 seconds to be able to run these through. As we were saying, for things like human terrain, demographics, we needed the ability to collect data that has never been traditionally collected. Where are the wells? Where are the hospitals? Why are the roads? What ages are doing? What wealth have they have? What kind of social structure are they doing? We had to make the systems flexible enough that we could bring all this information and still access it easily and quickly. And then we came across another problem we had, identities. If you have one record on one entity, it's correct. If you have 10 records, the odds are that you're starting to get degradation. By the time you get to 100 records, you're probably looking at maybe 10 duplicates out of 100. If you're looking at 1 million records, you're looking at thousands or even tens of thousands of duplicated records. My name, I could be down as Mark Ploszay, or I could be down as M. Ploszay, or I could be down as MP, or I could be an alias. But what we've learned now is to identify and draw together potential duplicate records over there. As you saw in the video, we ran that through. That was part of it, identifying duplicates. The IBM engineers originally came up with a product they called Identity Insight. And the point was that the engineers built it. It would go into millions of records and find duplicates for you. And then, because they were engineers, they said, make it so, and they automatically merged it. The intelligence analyst and the criminal intelligence analyst almost had a heart attack. You can't go into a court of law and say, oh, by the way, the machine decided for me. That's why we arrested your client. So what we've done now is we've changed to a recommendation engine. The systems now come down and say, out of the 250,000 records, I've got 150 that I think could be duplicates. And this is why. The same name, the same date of birth. Well, it doesn't have the same address. So maybe I'll give it an 8 instead of a 10. And we brought the human factor back into it. We brought it in so that they were the key people. They made the decisions. The engineers didn't like it. Okay, one of the other things we needed to do was come up with a flexible schema. When an organization has built a system like this, what they want is they don't want to have to go back to an organization or a company and say every time, gee, I need to put in one more field. Can you send out a technician and charge me massive amounts of money while they make that one change? Oh, and by the way, we'll be offline for a week while we do it. We've built it so that they can do it. Typically, to use something along one of our bases, it takes 5 days to train a user. And then we subject them to another 5 days, basically for their managers. And from that point on, they own the system. From that point on, they make the changes. They can, for a number of our more security-conscious banks, among others, they like the thought that when we leave the door, we leave. And then they can do what they like with their data. It's safe, it's secure. And timely data inputting. We were finding, especially for defense, they were doing, roughly around 100 to maybe 300 reports a day. They would write these out by hand, set them up, drop them into a clerk. The clerk would then type them into the system, and they were averaging anywhere between 3 days to 2 weeks before the information was actually going into the data systems. Now, there's an old adage out there, old intelligence is no intelligence. What we did was we designed it with drop-down menus to make it quick, easy, so the data goes in fast and you're ready to roll. And it's all visual. We're setting it up this way so you can see it. And this is where it leads up to, real-time modeling. That is a depiction of an actual terrorist network. Each of those is an individual node. You can see the lines of communications, how they talk to each other, where they communicate it. Well, running our tools through, using the geographic ones, the hotspots on the bottom, the heat matrix systems, we identified where the key node was, the leadership node. And it wasn't where you would think, in the center of the biggest node. It was actually there. We had multiple information going in, very little information going out. Very concise, complete reports. So we came up with the concept of real-time modeling. What we have is, this is a live system. It's actually interacting. If I remove nodes and I remove linkages, the system changes and it will revamp itself. It'll move it around. So I now have the option of going in saying, what happens if we remove this communication line? Where will they have to go now? This comes in very helpful also for financial investigations. Trace the money, follow the money, where's it going? So we came into the world of real-time world modeling. For law enforcement, the beauty about it is you can see how it affects an organized crime gang without having to go out and make arrests. You can also identify if it's going to bring up a power vacuum. Is there going to be a younger, more energetic, more radical person waiting to take over that slot when someone goes? And here's your end product, dissemination. I took my 5,000 records, I combined them down, I put them into one A4. I have a pattern of life there. What time do they get up? What time do they go down? What time do the communications go? Where are they on a Thursday? What coffee shop do they use? What vehicle are they associated with? I can put that into a chart. I can show high points. I can show satellite imagery. We can put all this into one visual representation. And now I've got 5 minutes to do something that we have never done before. Let me stress, this is something called Project Aurora. And this is not a concept. This has already finished its proof of concept. We're set for there. Do I have a lot of programmers, analysts, data handlers out there? If we do, you'll see some interesting numbers. As we were saying, data storage. The problem we were looking at, traditionally, we were all right. We could handle, a couple tetrabytes, no problem. But as you can see, on the right-hand side, this is the amount of useless data coming in. The amount of useful data on the left-hand side is dropping constantly. Okay, Project Aurora. Here's what we needed to do. They wanted to be able to do high-speed, live analytics on over 100 tetrabytes to start with. That was the initial. It had to be high-speed analytics. They did not want to put in a query in and then come back in 2 days. They wanted it live. They wanted to be able to find a path. These are people with multiple data systems. So you might have 5, 6, 8, a dozen databases. They wanted to find out if I'm looking at a nominal entity over here, what's their association over here? There's no direct link, but perhaps they know someone or they have a mobile phone and they've called someone and that someone has an address that is linked to that person. So it's finding hops over the path over there. And assisting the analyst. This is where we mentioned the recommendation engine, to ask, to tell, to find things of interest. And they wanted to do large data sets. 1 million records, a tetrabyte, a petabyte to be able to work with it. And they needed geospatial because they needed to be able to go in and say, all right, I'm looking at a point on the map. Within this point, find me all the information located within that area. And they had to create their own analytics. So as you can see here, one of the things is it had to be quick. It had to be reliable, and it had to enhance the abilities of the analyst. One thing we found out was analysts weren't used to having access to 1 trillion records. They would go in and a record would say, bring me back everything on Mr. Smith. Now, that's fine if you're using 1,000 records. If you're using 1 trillion records and you ask for Mr. Smith, you get back 2.8 million records. So we had to build in safeties over there. The system now comes back and says, are you really sure you want 2.8 million records? Then they have the option of saying yes, no, or redefining it as they go along. And here's how we did it. The blue part are the basic analysis that we've already had. Federated search. We can look across multiple databases and query. Intelligence repository. Suck all that database into one central area so you only had to make one query, not 5 anymore, or 10 or 20. The GIS interface. Again, right to the mapping and the visual analysis. This is off the shelf. This is material that we've had for years, and we've developed it constantly. But in order to handle this big data, we went with advanced visualization. We can now work in microseconds, which if you're looking at things like improvised explosive devices, air crash investigations, or telephone analysis, these are critical. We've built in business intelligence engines so that they can visualize it better. We brought in big data analytic engines to deal with terabytes and petabytes of data. One of the requirements they had was basically they wanted to bring back over 1.5 million responses to a query. They wanted it in under 1 minute and 30 seconds. We did it in 1 minute, 15 seconds to bring back over 1.86 million records. And then we put an entity relationship. That again was the thing, the recommendation engine. Who's out there, what we're going to do with it. And that's what we had today. 100 terabytes of information. It's looking at 1.7 million cell towers. It's doing 100 million unique phone numbers within this database. Over 120 million unique identities. And this is it. It deals with over 1 billion phone, fax, or SMS calls every day that it's active. There's over 1 billion entities within it that they can recognize, and they have over 1 trillion call data records involved in the system. This is up and operational at the moment. And with 58 seconds to go, before the hook comes out and I get dragged off, if anyone has any very quick questions, or I'll be around afterwards if I can answer any questions, please feel free.
Hogyha valakinek van esetleg valami kérdése, bár most éppen nem látom a fényektől, akkor nekem lesz kérdésem egy mindenképpen. Can you tell us more about the data sources? What can be real-life examples of data sources, and how it's difficult to integrate into real living systems?
We've dealt with everything. We've dealt with everything from financial records to cyber, where you're looking at thousands of IP. This, of course, was a telecommunications thing. Any basically large amount of fairly structured data can be incorporated for it.
And one personal, I'm really curious personally, how in one slide you mentioned that there was Facebook as one data source. How can you reach the private data of Facebook? So what is the solution to get data mining, to use data mining in Facebook?
Basically, it all comes down to the laws of the individual country that you're working in. In the UK, for instance, you can go in, but you can't go in and misrepresent yourself as a friend. So basically, you can just skim what you can find off the top. So it all depends on which laws you're actually working under and which jurisdiction. So in all honesty, the Facebook is one of the more secure systems out there.